Hello, my name is Miss Cloud. I hope you guys are having a great day. We are going to be talking about weathering soil and land movements. So please bear with me. There is a lot to cover in what I'm going to try to do in about 15 minutes or so. So if you need to pause, please do so. This is at your own pace. So some of the different essential questions that we can talk about are: what are the different types of weathering? What are three particles that create the soil? What are the different types of land movement? And what are the different layers of soil? Weathering is the process in which rocks are broken down due to exposure by causes occurring at the Earth's surface. So either by water, waves, wind, gravity, or glaciers. And all of these, as you can see, are created by wind, waves, and water. So physical weathering occurs when physical forces break the rocks into smaller pieces without changing the rock's mineral composition. So this increases the total surface of our rocks. Now, to be able to break things down. Now, with this being said, and I'll explain here in a second, there's multiple ways in how we can do all this. There's three different types of process that could be done: either frost wedging, unloading, and biological activities. So frost wedging is when water works its way into the cracks of the rocks. Water freezes, then expands, makes the cracks bigger, and keeps on doing it until the rocks is broken apart. Most common definitely in the mountainous regions. Uploading is large masses of igneous rocks exposed through uplifts of erosion when it causes the outer layers of the rocks to expand. Um, so what happens, like underneath the rock, like the top of the mountains and such, more pressure keeps pushing it up, again, metamorphic rocks, and the rocks start actually popping up. And here's an example of unloading. So with that and everything, oh my bad. So with that, we have rocks that are being pushed up into the pushing up like from underneath, and as you guys can see, the rocks are being broken apart. Uh, so again, rocks are being broken apart. Biological activities is when we got plants or plant roots that are growing into it. So let's think about our ecological successions and our lichens and moss. Starting to bury their roots into the rocks, and this is the basic starts of how the rocks start breaking apart. Um, the rocks are wedged, growing apart. Animals could start burying themselves in there or start pulling rocks apart, breaking them down a little bit. Humans, as we break things up apart, especially with our forests and everything, or if we're using it for construction wise, that's another thing that we could do as we break these rocks apart. Other ways is abrasion, the wearing away by wind, water, and glaciers. Makes it nice and smooth a little bit. Uh, Grinding motion type deal against rocks, or minerals against minerals. Now let's talk about chemical weathering. Is the breakdown of the rock and changes the chemical composition of that rock. So like when minerals are changed into a different substance, and it's usually by water vapors, acids, and or oxygen. Water is a huge factor when it comes to chemical weathering. Now let me explain. Here's an example as to how we could tell the difference between physical weathering and chemical weathering. Physical weathering is if I take a marshmallow and rip it apart. That's physical weathering. But if I take um but if I take like put it together or like rip it apart, stick them back together, and then put that same marshmallow over a fire. That is going to be a chemical weathering, because what happens when the marshmallows get burned and everything? The actual marshmallow starts actually chemically changing its substance. It's the same thing with rocks. You rip that rock apart, or somehow that rock gets ripped apart and broken down. Whereas chemical weathering, not only is that rock broken down apart, but its chemical composition changes. And again, water is the most important agent of a chemical weathering, absorbs the gas around from the atmosphere and the ground, and changes not only the rock structure, but can change a little bit of everything else around it. Soil. Now, basically breaking down these rocks creates our soil, along with dead plants and animals. Soil is the weathering produces layers of rocks and mineral fragments called regolith, supports the growth of animals. And we also have to have like the organic side to it. But soil is basically all the rocks and minerals coming together and broken down from the rocks. Now, soil has 4 major components. We got ourselves mineral matter, broken down rocks, which is like 45% of it. We have organic matter, which is like 5%, water, 25%, and air, which is 25%. Now, are these going to be the exact percentage? That's an absolute no, because not all soils are the same. If so, we would all have the same plants and everything. So everything can be a little bit different. For example, if you're in a desert soil area, you're going to have significantly less amount of water. A lot more air, mineral matters, and organic matters, but not as much water as soil. This pie chart is the optimal, or the best way to do it. It is the best way, the best type of soil to have. Now, the soil texture contains particles of different size, those based on clay, silt, and sand in soil. And each of them, as you can see, not all soil is the same. Now, soil formation comes from the parent materials of the different types of bedrocks it comes from, the different types of minerals that it comes from, where it comes from, what type of organic material's been there. But basically where the rocks come from, like the parent material, where it's come from and where it gets to. And parent material is unconsolidated, means loose, not cemented together. Basically, when they're solid rock, all that material just stays in that same place. Eventually, the nutrients come from that same area. If it's been moved, it's considered transported soil. Long period of time. Let's talk about our ecological succession. The longer the soil has been breaking down, the more nutrients comes out from it. Climate can have a huge impact as to what type of temperatures has a huge impact on how thick the soil can be or how quickly the soil is created. So like variations in temperature, precipitations, influence of the rate, depth, types of weathering, the amount of precipitation, what type of chemicals are in it, can have a huge impact on how the soil is formed. Organisms are a huge impact as to how plants start growing. The nutrients. This helps get our organic materials for the soil. So plants are the main source of the organic matter in soil. Animals do take up microorganisms, but plants are the biggest ones. Slope has a huge impact. If you're on a steep slope, nothing stays on there easily. It takes way too long for it to grow because gravity has a huge impact. If it's flat, there's very little erosion. Water soaks into it because it stays in there. There's no movement whatsoever, meaning that it's going to be lush and thick with materials of plants and animals and soil. Now let's talk about soil profile. The O layer is the organic material. Dark, rich materials gives us the nutrients that we need. Leaching is the removal of nutrients or toxins in the soil. So all the nutrients are in here eventually goes down through, and this is the part where it's lack of nutrients. So the sizes of the material, we need sand, silt, or clay. 0.2 to 0.06 millimeters, and so on down. And as you can tell, the smaller the size, the harder it is for soil or materials to pass through. So we got the A horizon, commonly known as the topsoil. A horizon is like literally right below the O horizon, where you have the rich amount of nutrients in there based on all the dead organisms and materials. Teeming with life. B horizon is subsoil, where we have most of our materials still there, but like lots of the nutrients have been taken out of it because it's all in the A layer. C horizon is partial, part rock, part soil, not much nutrients, and then we eventually get into the bedrocks. There is really not a whole lot of stuff going down here. Plants tend to stay in the A horizon, B at most. C, there is no living animals or materials. Earth's land surface is the transfer of rocks downslope due to mass movement. There's multiple different things. This can also impact our soils. So trigger mass movements, or gravity is the biggest one. Earthquakes can happen, tornadoes, not so much, but could happen, avalanches, you name it. But gravity is the main force that brings all materials down from the rock, from the mountains and such. Water. Water is your best friend, but it also has the most amount of forces that can change rocks, minerals, and land. It can change so much. So the heavy rains, rapid snow melting can saturate into the soils, much easier so than others. The steepness of the slope, the steeper it is, the less likely the soil will stay there. This also means that there is a bigger chance that a mass movement can occur, meaning rocks falling down, materials falling down as well. This could cause major problems. Okay, not only for us, but for animals as well. If we remove vegetation, root, plant are the hugest things that keep the soil together. Okay, the living thing that we need is plant. If we take away the plants, so deforestation, we kill off all the plants. We don't monitor our land and such, is going to have an impact on what type of mass movement we're going to have. So again, roots keep the soil together. Earthquakes, again, shaking up the land. Earthquakes shake it up and can cause major issues, especially out towards the west. It's going to have major issues because not everything is stable. Most of that is mountains out there. They don't have flat surfaces. So if you include earthquakes plus a slope, you're going to have rocks falling down on top of you. So we got different types of mass movements, and that's based on the material it is, the slope of it is, and what's keeping the soil together. So we got rock falls. These are rocks that are falling freely through the air. So as you guys can see at this picture right here, we got rocks that are in the middle of this road, this area, and it has caused a whole bunch of rocks falling down. Praying to God that nobody was in there. Slides. These are literally like a slide on a playground. You got slabs of materials falling down or sliding down and causing a disruption. As you can see, we have some vehicles that are stopping the roads, but they can come really fast. And it's the speed that can happen. Like, as you can see, this is very steep and there's not much. Slides right down. Any type of movement, gravity, anything could happen. Slumps tend to be very slow. They don't go as fast, but they're kind of like a bunch of the soil just kind of slumps down. And it doesn't take much. It doesn't take long. It's not too bad, and it's very thick with clay. Like one of the layers of this area can have like a lot of clay, and if enough water is in there, it will make the clay slippery, which then causes the soil to just move. Flows are almost like your floods, but instead it's going to be like a whole bunch of mud, rocks, and soil coming along with it. It's not just water, it's everything in the soil. And they're very fast. This is going to happen when you're going to have more mountainous, where there's not as much rocks, or not much water. And when there is water, all of it soaks up, and then again, all of it just kind of whooshes down. It just takes everything with it. And creeps are the slowest mass movement. It usually takes a couple milliliters over time, over years. These are the slowest. You will not be able to see nor feel unless you see some sort of evidence, like tree trunks looking a little funky. Instead of straight up and down, it's going to be kind of like curved. So these are the different types of mass movements. At this time, if you have any questions, please come talk to me, and I hope you guys all have a great day. Bye.